Have you ever wondered why a moving skateboard stops when it collides with a rock? Or why a billiard ball suddenly changes direction when it strikes another ball on the pool table? These events, and many others in our everyday lives, are governed by a fundamental principle in physics known as the conservation of momentum. So, what exactly is momentum? Think about when you're pushing a grocery cart. The heavier the cart and the faster you push it, the more difficult it will be to stop. That's momentum, a measure of an object's motion, depending on its mass and velocity. Now, when we talk about the conservation of momentum, we're referring to a key principle. In a closed system, the total momentum before an event must be equal to the total momentum after the event. This principle holds true regardless of whether the event is a collision between two cars, a rocket launching into space, or even a figure skater spinning on ice. Consider a game of pool. When the white cue ball strikes another, both balls don't just come to a halt. Instead, they move off in different directions. Why? Because the total momentum, the combined momentum of both balls, is conserved. It's just redistributed between the two balls. Similarly, when a rocket launches, it doesn't just magically lift off the ground. It expels gas downwards at high speed, and by doing so, propels itself upwards. Again, the total momentum is conserved. The downward momentum of the expelled gas is equal to the upward momentum of the rocket. In the case of a spinning figure skater, when they pull their arms in, they spin faster. Why? Because the total momentum in the system is conserved. As the skater reduces their radius, their rotational speed increases to maintain the same total momentum. So, what have we learned today? Firstly, momentum is a measure of an object's motion, which depends on its mass and velocity. Secondly, the principle of conservation of momentum tells us that in a closed system, the total momentum before an event is equal to the total momentum after the event. This principle is universal, applying to everything from collisions on a pool table to rockets launching into space. Finally, we've seen how this principle plays out in a variety of everyday scenarios, helping us to better understand the world around us. The next time you see a skateboard skid to a stop, a rocket launch, or a figure skater spin, remember the principle of conservation of momentum. It's not just a theory locked away in the physics textbook, but a fundamental principle shaping our everyday experiences.